Safrole is a naturally occurring organic compound commonly found in several plants or trees, like the sassafras tree, which has safrole in its root bark. Lab coats even made a video about its extraction. Poor man's chemist even did a steam distillation, just like lab coats, of the sassafras root bark and got safrole as an essential oil. Safrole has a beautiful aroma and it kind of smells like root beer. Chemically, safrole belongs to a class of compounds known as phenylpropenes. Its structure consists of a benzene ring bonded to a methylene dioxy group and a propanol side chain. Safrole also has a group called 1,3-benzodioxyl, where it just has a benzene ring and a methylene dioxy group. This is also present in compounds like myristicin and piperin. Myristicin is a compound in nutmeg that has hallucinogenic properties, and piperin is responsible for that pungency of black pepper. You're probably wondering why I'm telling you this, and really, I just want to make safrole. And I need a starting compound. Both of these could theoretically work, but I actually found something pretty interesting. I found a super special paper that had some interesting reactions. And they started from something called catechol or eugenol and went to 4-allo-catechol. I promise this will make sense in a second. They had this reaction map, and I saw that we could get safrole either from catechol or eugenol. And the best part is I have eugenol on hand. All we have to do is just make this methylene dioxy bridge, and we have our safrole. And this paper basically just hand delivers this shit right to us. And the best part is, I don't have to use any critical thinking skills and I can just monkey brain this procedure. Now, I know some of you are thinking, well, what about the DEA hating this? My first thing to say is f you. And the second is it's technically not illegal. Now, safrole's used in a very specific chemical synthesis, but I'm not going to tell you that. It is on the DEA's List 1 chemical list, and they're chemicals that are used to manufacture certain controlled substances. So when people have large amounts of safrole, it's really not used to make root beer. Sorry, lab coats.
You know, the moral is not to make psychedelics illegally or not to make MDMA, but what do you think can be learned from what happened to you?
Don't get caught.
American sassafras albendum oil is distilled under vacuum to isolate safrole from other phenylpropenes and terpenoids.
I am blessed by the heavenly gods above. With safrole in my hands, I feel their love. In every drop their grace I see, a gift from heavens, setting me free. I'm just messing with you. It was just an absolute bitch to make. Well, I guess I can start now. So, to this round bottom boiling flask, I added 250 milliliters of toluene. Now, you may also notice that my stir bar is pretty yellow. That's just the color grading. I swear it's pretty much white. Next, we need our starting material, and that's going to be 8.01 grams of eugenol. Eugenol is also used in the dental industry, where they use it for dental cement, filler, or curative materials. Now we need the main star of this entire reaction, and that's going to be 8.8 grams of aluminum chloride. When we get to the mechanism, I'll show you why this is important. Shortly after the addition, our aluminum chloride actually turned this reddish-orange color. In a separatory funnel, 18.25 grams of pyridine was added. My pyridine has this piss-like color to it, and that's just because it's kind of old. That smell is still kicking though, I'll be honest on that one. The pyridine had to be added dropwise and not all at once. Now I kind of get it, the last time I did this with vanillin, it kind of exploded out of the flask, but this time it really didn't do anything. Now, all we have to do is just heat this under reflux for 5 hours. The solution started cloudy, then got kind of orange, then went clear, and then started to reflux. The reflux was calm and normal at the beginning, and then it turned out to be Walmart on Black Friday. After the 5 hours, it kind of turned into this weird, dull-looking beige with some of these blue spots around it. Now, the paper describes this as a clear yellow organic layer, but I do not see a clear organic yellow layer, though we do have the result of the reaction at the bottom. I'm now supposed to decant all of the organic layer off of this solid that we have at the bottom. Now it did come out this sort of yellowish layer, so that did make me more at ease. The remainder of the solid now needs to be dissolved in 6.4 molar hydrochloric acid, and we're going to use about 300 milliliters to do this. I thought this would make it dissolve, kind of like Ava Tyson's career, and it really didn't do anything. I tried using a glass stir rod to break it up, however, it really didn't do anything and just made smaller chunks. With a hot plate turned on, I just melted it, and it seemed to work. This time, it went into our acidified aqueous layer. It did take some time, and some chunks took longer, however, we eventually got everything to dissolve. There was also this random black compound in here, and it was making this really cool tornado. I don't really know what it is, but it looks pretty cool. It was a light orange, and then it kind of turned to a reddish orange at the end.
Boy, do I have something for you. We have a mechanism on this beautifully crafted ChemDraw. First, eugenol is being converted into 4L-ill-catechol. This works as aluminum chloride is a Lewis acid that can accept a lone pair of electrons of the methoxy and hydroxy oxygen. Electron pairs on both the methoxy and hydroxy oxygens will attack the central aluminum atom, and chloride will leave as a leaving group. The chlorine ion is then nucleophilic and attacks the methyl group that has a partial positive charge. It will also attack the hydrogen in the hydroxy group. Both of these result in a complex. This complex can then be decomposed to give our respective 4L-ill-catechol.
We now need to extract our 4-allyl-catechol, and we're going to put this into a separatory funnel. We're going to be using diethyl ether as our extraction solvent, so I put it in the original flask where we did our first reaction. This was just to wash it out, and then I poured it into our separatory funnel to do our extraction. We're going to do a total of 3 100 milliliter ether solvent extractions. After doing the 3 ether extractions, we now need to wash this and get any water-soluble impurity out. We're going to do 3 100 milliliter water washings, and then we can go on to the next step. I also wanted to show our original reaction mixture, and it has this beautiful deep red after all the extractions. Once our ether was washed with water, we now need to dry it, and we're going to use sodium sulfate. I left it in for about 10 to 15 minutes before we moved on to our next step. It cleared our organic layer pretty well, and I also had to add some molecular sieves to further get the water out. The last thing that we have to do is just remove the solvent. The paper does use a rotovap, but I don't have one. Now, I could have done this under reduced pressure, and I probably should have, but since ether is such a low boiling point, I thought I could just do it by a normal distillation. As we distill more and more of the solvent off, it actually took on more of a black color. I eventually could see these black/purple-like droplets coming towards the bottom in this rain-like fashion. It was a very mesmerizing process to watch, and I thought it was really unique. With our solvent almost gone, we can see our product, and it's this deep purple liquid. This is where a reduced pressure distillation would have been much superior, as the ether had some issues trying to fully get out of the flask at the end. Now, I did distill the ether from starting fluids, so there could be some heptane contamination. When all the bubbles stopped, that's when I stopped the distillation. I thought I was able to just pipette our product out, however, I noticed that there was still some solvent in there. My solution to this was just to pipette the solvent out. It didn't seem to be that miscible with our product, so I just decided to do that. I was able to get our product out, however, I had to use heat because this liquid had such a high viscosity that it wouldn't go in the pipette that easily, and it would also stay in the pipette when I did that. Anyway, yield 3.88 grams, percent yield 52.9%. I also lost a lot of it in these pipettes, so I know I had a higher percent yield. Now that we have 4-allyl-catechol, I added 50 milliliters of DMSO and 5 milliliters of DCM. After that, I equipped the flask with a Claisen head, a addition funnel, and a reflux condenser. Since our product is so viscous, I had to put it on a hot plate to transfer it. We're going to transfer our 4-allyl-catechol into some DMSO, and we're going to use 10 milliliters. Now, the procedure did call for 2.5 grams of sodium hydroxide, however, I just didn't have any. Now, I did a little bit of research online, and I found someone called Cyclone Knight. Not only did he save my ass, but he also made me question my own sexuality. He cooked up a procedure that used potassium carbonate instead, so I added 4.39 grams of potassium carbonate into 10 milliliters of water. After I added our 4-allyl-catechol into our DMSO, it had this beautiful violet blue color. I wasn't expecting this color change, and it kind of freaked me out when I first saw it. As usual, when I transferred the 4-allyl-catechol, it got stuck in my pipette. I started the reaction mixture, and once it got to 120 degrees, I started adding in our potassium carbonate solution. It's just hard to see on camera. After that addition, I started adding our 4-allyl solution drip by drip. I did kind of let it floodgate in the beginning, but you can see when the solution reaches the reaction mixture, it has a beautiful color. Though shortly after, as I was heating it up, it kind of turned into a poop brown. And near the end of the addition, I kind of just floodgated it. Now, I do have a reflux. This is mainly water and or DCM. Now, I did add some extra DCM to our addition funnel as I'm probably going to lose some. Now, Cyclonite's procedure had a very long reaction time, 5 hours total with additions, and the one that I was following was 45 minutes. I didn't really know whose time to use, so I just did about 2 hours. I also replaced any lost DCM every so often, and I added about 5 to 10 milliliters at a time. When the reaction was over, I let it cool down, and then I added 50 milliliters of distilled water.
Okay, next mechanism, you silly cunts. 4-allyl catechol will be deprotonated by the base. In our case, potassium carbonate. It can make hydroxide ions in water as well. This biphenolate from deprotonating 4-allyl catechol can then attack dichloromethane, having chlorine leave as a leaving group. The other phenolate can attack the same dichloromethane again, causing the other chlorine to leave and thus create our methylene-deoxy bridge. This creates safrole.
After letting it cool and adding the water, a brown liquid was kind of surrounding the flask. In their paper, the safrole at the end is brown, so I was pretty excited to see this brown in the flask. We now need to extract with ether, so I decanted the resulting mixture and I put it into a separatory funnel. This black-like substance was accumulating at the bottom, and I was quite curious as to what this was. We're going to extract with 3 25ml portions of diethyl ether, and I decided to start out by rinsing out our reaction flask. I was excited to see the color of the ether as it had a light brown hue to it, and it was kind of cloudy. Once I took all of our ether extractions and put them into one flask, I added some sodium sulfate to dry it out. And of course, I added some more molecular sieves to fully take the water out. After that was finished, I filtered it out so we could start a distillation. I also washed the flask out a little bit more, and I filtered that as well. I set it for another simple distillation as the paper used their fancy rotovap. Let the distillation begin. The paper mentioned that the ending oil would be brown, and I was ready to touch myself all night long after seeing mine. When I thought all the solvent was gone, I started pipetting it out. I was extremely pleasured to see a brown oil. I got a drum vial and I started collecting it. Now, the unfortunate part is I forgot to wash my ether extracts, and I don't know how pure this really is. It was annoying me bad enough that I really wanted to purify it as much as I could. So I asked Chemistry Jesus, which really just is that chemist, and he gave me a good idea. So I set up for a steam distillation. All I did was put our supposed safrole in there, and I added about 150 milliliters of distilled water. I turned it up as hot as I could, and I got real hot and steamy in there. So much so, it decided to leak its contents out. And I'm talking about our steam distillation. And we can see this beautiful blob of supposed safrole at the bottom. When it was all finished, I decided to pull it out with a pipette. I did have a lot of trouble actually getting it into the pipette, and then once it was in the pipette, it just kept doing weird things. So I decided to do it a different way. Yeah, I used ether. All that's left to do is just boil off the ether, and we should have our safrole. I see an oil of beautiful complexion, which smells like a beautiful concoction of root beer flavor and candy store. I ended up with about 1.40 grams with a percent yield of 24.8%. Safrole just stopped coming over after a while in the steam distillation, but I know there was still some safrole left in the flask. I kind of regret not putting more effort into the pipette and doing an ether extraction. Steam distillations aren't really the best for purification, but I'm still glad I did it as I really don't know what's in that brown oil. I know this isn't pure, as a week later I saw these little white, oily splotches on the inside of the drum. While there really wasn't a lot of it, and it was still mainly the oil, it still showed that it really wasn't that pure. Now, I just want to say, you can't fully trust me right now, as I don't have the analysis to show you what this compound is. I'm purely going off of research and papers and the smell of it. This needs to be sent into a lab to be analyzed and to show what I truly have. Anyway, thank you so much for watching, and huge shout out to all my Patreon supporters. Thank you so much for supporting the channel, and I could not do this without you. In the next video, well, f it, let's just make some crack.